So students, we are back again from mock test for you. Here I am Rahul and we are hereby again going to discuss the continuation of the chapter we started in the previous class, that is actually kinematics, and we are in the second class of it. That you can see on the caption on the board that we are going to do the non-uniform motion, which is related to application of calculus. So when we are thinking about the application of calculus in motion, we need to know about the very basic about the instantaneous motion, that is a motion related properties at any instant, at any moment, like instantaneous velocity, instantaneous acceleration, and all these things in terms of calculus specifically, because there is some term, there is some representation that we are going to describe in this particular content of our class today, where we are going to describe the entire thing of motion of variable system, like variable acceleration, variable distance obviously with time, variable retardation, variable you can say that variable types of velocity. So this type entire thing regarding the non-uniformity of the motion that we are going to discuss in this particular class today, and hopefully it will be very much interesting for you as always in the past classes. Now let's concentrate on a very basic thing about function, that we know about function in calculus. Whether you have maths or don't have in class 11, 12, that you don't need to be worried, because here we are going to discuss all the mathematics related terms in motion in terms of calculus here. So don't need to get tensed. Now the thing is that first we are starting with the concept of function, which is most important in this particular class. That y equals to function of x, we need it very much, y equals to function of x, because we know here y is a dependent variable and x is an independent variable or fundamental variable. This x we can choose, we can change its value according to our wish, but here the y is going to be changed with respect to x. So if x is changing, y is changing correspondingly. So this direct or indirect relationship between two variables in terms of mathematics, it's actually represented as this notation, which is called function. So here y is a function of x, so y is the dependent variable and x is the independent variable. Now from here, when we are going to discuss this independent and dependent variable from this particular idea, we need to express that why in motion these functional relationships are important. But before going into this, we need to know one thing, that when y is changing, y changes with x. When y changes with x, this parameter we know that y is changing with x. So that means x we can choose to be changed independently, and with respect to that y is changing. So when x is changing and y is changing with it, so in terms of normal unitary method, we can find out the rate of change of y definitely with respect to x. Suppose I am taking the value of x is changing from x plus del x, where del x is the increment of x, and increment, you know, increment or decrement, whatever be the value of it, it must be a change. So del x is the change here, and due to suppose it is changing positive, that means del x, if x is increasing, suppose I am taking it, y is also increasing. So there is a positive change, that when x changes from x to x plus del x, let y changes from y to y plus delta y. Now from here we can say, for a change of x, that is del x, we are getting a change of y, that is del y. So if I say a simple unitary method like that, for del x change of x, we got a del y change of y. So for unit change of x, that is actually the value of 1, we have the change of y with respect to x as del y by del x. And what was Sir Isaac Newton's proposal in Principia of Calculus, the big Bible of calculus, that you know that if limit of del x tends to 0, this delta y by delta x can be written as dy by dx. Actually this pronunciation dy by dx is utter wrong, because dy by dx is not a division here. It's not a revision dy by dx. It is simply a mathematical operation like all other mathematical operations like addition, multiplication, subtraction, division. Just like that, differentiation is just another mathematical operation where you can write dy dx as what? Now you should write as ddx of y. These ddx means what? This means the rate of change. This means the rate of change with respect to x. If it was not x, it could have been t, it could have been z, it could have been theta. But in that terms, it has to be y has to be a function of z or function of time t or function of angle theta, whatever. So if one variable is changing, it's showing a transformation with respect to another one, then definitely they are related as a functional relationship. And when these independent and dependent variables change with respect to each other is actually represented in terms of calculus, which is known as differential calculus, where we measure the rate of change of any variable with respect to other variables. Suppose you are going to select the total Indian cricket team and you are selecting players from Kerala, from Maharashtra, from Karnataka, from UP, from Delhi, from Jammu Kashmir, from Andhra Pradesh, from West Bengal, from Assam, everywhere. So whenever you are thinking about state-wise, you are dividing the whole country into some smaller states, and whenever you compile all these states together, you are getting back the whole country. So if the whole country, if we take it x and you differentiate by state, each state will be represented as dx. And if you summed all these dx together, you will get back the x. So this summation of all these dx together, this is called the integration. We know now in English language we enough have written about national integration. So all the states, all the people are integrated in the common name of India. So just like that, when we differentiate, when we segregate each and every variable in different parts, that is called differentiation. We study them individually, we observe them individually, and if we want to have the entire thing in observation, we have to sum them up. And we have to represent the whole thing as the entire quantity. So that is called the summation of all the individual identities that make the whole thing. So that is called the integration. So differentiation and integration are just like their reverse process to each other. If I want to differentiate a quantity, I have to segregate those quantities by small parts of each other. But when I am integrating the whole thing, that I am getting back the original quantity. So if I differentiate something, I will get a result, and definitely if I integrate those results, I will get the entire thing which I have differentiated. So integration and differentiation, integral calculus and differential calculus, they are just opposite to each other. See, if I draw a graph like this, suppose this is y and this is x-axis, you know it very well. And if one particular variable is changing, that is represented in y with respect to x, that at any moment, suppose here the quantity is x, where it is y, where this quantity is x plus del x, where this quantity is y plus delta y. So ultimately this is the change, that is called delta y, and this is the change, this is called delta x. So this is actually the tangent you are getting from the graph. If you draw a tangent, you will make an angle. So from any graph, if you draw the tan theta, if you get the tan theta of the graph, that is del y by del x, and in where limit tends to 0 measurement, it will be dy by dx. So this is actually the slope of the graph. So slope of the graph is often represented by dy dx, and dy dx is also called the rate of change. So slope of any graph, whatever be the nature of the graph, it can be a curved line, it can be a straight line, it can be a circle, it can be an ellipse, whatever be it, the slope of the graph is always represented by the rate of change variable, rate of change of that particular variable with respect to the another one. Which variable's rate of change? Definitely the dependent variable's rate of change. Now from here, whatever this mathematical introduction I have given, why it is so much relevant to this chapter of physics, because we don't need that much of calculus at the beginning, but still we need calculus to know about the kinematics, where we have to discuss the non-uniformity of the motion, where we directly need to apply the calculus concept. Now, how it is related, if we go for the detailed analysis, you know very well when the object is changing its position at every time, so definitely the displacement is a function of time. When the displacement is function of time, that means the particle is in motion. That means if the time variable is changing, automatically the position of the object has to change. And position of the object has to change means what? When the position of the object changes, that means it is having displacement. It is in motion. So when the displacement is changing with time, so that means there is velocity, there is speed, there is distance, and there is non-zero displacement. May or may not be, because displacement can be zero, though the distance cannot, as the total actual path can not ever be zero, but the displacement may be zero if the initial and the final positions are same. Now from here, what we are going to discuss, now if this is function of t, that means s changes with respect to time. So here s is the displacement or the distance. We know that velocity is the rate of change of displacement, or in terms of mathematics you can write it as displacement by time is known as the velocity, or distance by time is known as the speed. Now in terms of calculus, the rate of change is often called as ddx, where y is function of x, the rate of change operator, we write it as ddx. Now when it is function of t, this ddx will be referred to as ddt, or the velocity should be represented by, like y was function of x, so rate of change we wrote as dy dx. Here we have to write the rate of change of s with respect to t as ds dt. Sometimes we pronounce it by ds by dt, and by mathematics it is utter wrong, because ds by dt does not stand, because it is not a division anymore. It is a different mathematical operation known as differentiation, which implies the rate of change of one variable. So v stands for, the velocity stands for ds dt. Now see what I told, that when this del t or this del x, ds dt is actually what? It is limit of del t tends to 0, del s by del t. Del t tends to 0 means it is a negligible instant of time. So it is negligible instant of time. That means it is representing the velocity at a time which is almost close to 0 but never equals to 0. So this velocity, what we represent by ds dt, it is also called v instantaneous, or instantaneous velocity. Velocity at a particular moment which is almost negligible. Velocity at a particular instant which is so close to 0. Now what we need actually, that velocity is instantaneous ds dt, acceleration, instantaneous acceleration is dA dt, acceleration is dv dt, because when velocity is changing with time, like displacement is changing with time, we have velocity. Now if velocity is changing with time, we should write the acceleration as dv dt, and it should be called instantaneous acceleration. It should be called instantaneous acceleration again, because the del t time has to be very much negligible. Now I just told a while ago that dy dx is actually the slope of the graph. So whenever you will represent any graph, like you will represent like this, when s versus t, you will represent like this. So s and t, suppose the graph is like this. So if you are drawing the slope at any point, you will get the slope. Here the angle is theta. So m tan theta will give you what? The slope of the graph, that is ds dt. And ds dt is what? Is velocity. So in a displacement time graph, always remember, in a displacement time graph, that is the tan theta or the slope, that is ds dt, what will be it? Your velocity or speed. Now the same thing, if it would have been a velocity time graph, suppose it is a velocity time graph, so this would have been acceleration. So if it is a velocity time graph, then again, if you get the tan theta, that will be the slope, that is dv dt, and which is actually acceleration, that is a. So these are the actual correlation between the application of calculus and how these applicated fields of the calculus of the rate of change of two variables between each other is how it is related to physics in terms of motion, like displacement, velocity and acceleration. Now from here we need to discuss one very important thing, that is there are some formula which are very much related in physics, in mathematics, and in physics they are so important. How they are related in physics? Like if y is function of x, this function can be anything. It can be a constant, whatever, it can be a constant. If you differentiate a constant like ddx of any constant, constant means which is not having any change, the thing which is not being changed with time, with any parameter, so its rate of change has to be 0. So differentiation of any constant 0 we know. Then it can be an algebraic function. If it is an algebraic function, then it can be a logarithmic function. It can be trigonometric function. So lot of functions it can be. So automatically the dy dx will have different formulas in different occasion. Now see, one thing I am going to express, that is suppose y is function of x. So I take dy dx, that is what? That is called the first order differentiation. That is called the first order differentiation. And if I again differentiate this, so it will be a second order differentiation, and it is represented as what? It is represented as d2y by dx square. It is called second order differentiation. This is called second order differentiation. And how it is relevant in physics? Suppose I have written that displacement is function of time. So if I have written ds dt, that you can write as v. That is the first order differentiation of, what is that? First order differentiation of displacement. Now that is, you can write as velocity. Now if I do the second order, that is I have to differentiate this one. So second order differentiation will be d2s by dt square. And this is the second order differentiation. How we got it? It is actually the differentiation of the first order, because two times successively I have differentiated the main function, that is s. So ddt of ds dt, this is actually ds dt is what? Velocity. If I put it here, it is actually showing dv dt, that is acceleration. So if I differentiate the displacement, velocity is often represented by the first order differentiation of the displacement, and if I do represent the acceleration, that is the first order differentiation of velocity, and obviously it is the second order differentiation of displacement. So these are the basic notations where you can express velocity and acceleration when the displacement and velocities are changing with time. But now we are going to discuss one very important property over here, and how we are going to discuss it, that is so important. That is, if the displacement or the velocity is not related with time, like what I am trying to say, like if velocity is a function of time, then acceleration is surely dv dt. It's right, because it is depending on time. But suppose velocity is not a function of time, like this. If the velocity is not a function of time, then what will be the formation of acceleration? Because we can't take this dv dt anymore. But how? See, the velocity, if it is either a time function or it has to be a space function. If it is dependent on space, that is on distance or displacement, then we know the standard formula of acceleration is dv dt. So we can adjust little bit by dv ds into ds dt, something like this. So ds ds will cancel out by in terms of maths conceptually, so though it is not be cancelable in proper mathematics. So dimensionally ds ds will cancel out. So finally it will be looking like what? See, it is looking like v. Acceleration stands for v dv ds. So remember, this formula of acceleration only holds good when v is function of t. when v is function of s, we need to apply this formula. So these two are very true. The same formula and correlated by here and there to different aspects. But when the velocity is function of displacement, we need to apply this formula for acceleration. When velocity is function of time, we need to apply this formula for acceleration. They are both true, both equally strong in terms of their own field. Now here we need to apply some cases like the different functions we have, and we need to differentiate different functions to get different parameters in physics. So first of all, let us have some basic functions in calculus, differential calculus, like suppose y equals to x to the power n. So definitely if I differentiate it, it is dy dx, that should be ddx of x to the power n. So it has to be nx to the power n minus 1, and you did not need to know anything about the detailing of how this calculus formula came, because you have studied in maths. We are just recapitulating because it is relevant in physics and equally important. Now suppose let's take an example. Suppose y is x cube, or let's take x to the power 6. Then obviously dy dx will be just like ddx of x to the power 6. 6 is taken as x to the power n. So it is 6x to the power 5. Simple as that differentiation. Suppose I have given y equals to 5x. You know, suppose if I have taken y equals to x, x means x to the power 1. Then dy dx, if I write, it is ddx of x. So ddx of x means it will be 1 into x to the power 1 minus 1. So something to the power 0 is 1. So finally it is 1. So always remember, if I have variables like this, that ddz of z equals to 1. If I have ddx of x, that equals to 1. dd theta of theta, that is equals to 1. ddt of t, that is equals to 1. When you are differentiating a variable with respect to the same variable, your differentiation result is always 1. Suppose you are differentiating a constant. Suppose you are differentiating 100. So 100 is a number which is 100 today, will be 100 after 120 years, 1000 years, 1 lakh of years, 1 million years ago 100 was 100. So ddx of 100 means it's a number which is not going to be changed anywhere, anytime. So it's a constant. So its differentiation is 0. So whenever you are going to differentiate any constant, that constant means it is invariant, which cannot be changed with anything. So its differentiation has to be 0. As simple as that. Now from here, suppose you are given a particular variable situation like this. Suppose y is given 3x cube minus 4x square plus 6x minus 7. So this is the notification of the entire polynomial, that y equals to 3x cube minus 4x square plus 6x minus 7. So if I differentiate this, what is the basic fundamental procedure? We know that I have to take this 3 out, that ddx of x cube minus 4 ddx of x square plus 6 ddx of x minus ddx of 7. So finally it becomes ddx of x cube will become just like this. So it will be 3x square, 3 multiplies, so it will be 9x square minus 8x plus it is 6 ddx of x, that is 6. It has to be 0, and 0 you need not to write. So this will be a simplest approach of differentiation when you are having it in physics, but not only ordinarily like y equals to x to the power n, or this type of variables will be there. So definitely there can be some variables like y equals to e to the power x. The exponential is a variable which remains invariant under both differentiation and integration. So if I take this dy dx, it has to be ddx of e to the power x, so it has to become e to the power x, as simple as that. If y equals to log x to the base e, so dy dx we can write it as ddx of log x, so it has to be 1 by x, like this. So this is the entire way of differentiation, but apart from this we have the most important trigonometrical function, basic 3 functions we have. If I differentiate ddx of sine x, you need to remember this formula several times, it will be cos x. If I represent the differentiation like ddx of sine mx, where m is a constant which is not equals to 0. So if I differentiate this sin mx, it will be this m coming out as a constant. So it is m cos mx. Again, if m not equals to 0, if I differentiate, okay, let's take the ordinary thing first. ddx of cos x, if I write, then it will be a simple differentiation, that cos x will be minus of sin x. Again, if I differentiate under the same condition, that m not equals to 0, then ddx of cos mx has to be minus m sin mx. So these are the important things we have for this particular option, which is known as the differential parameters we have for sine, cos and all. Like the same way, if I differentiate ddx of tan x, if I do, it will be simply sec square x. So these are the variable functions representation on this particular field, on this particular term we have. So this is going to have a very, very important thing to express when we are expressing the entire terms of calculus by this manner. Now, why it is important in physics, we have already discussed that displacement's rate of change is velocity, velocity's rate of change is acceleration, and we can represent the rate of change operation entirely by terms of differential calculus. So these things are very much relevant and important in physics. But how they are important, how they are having some relevance and importance, that we are going to discuss in this particular class. Now suppose one thing I am going to express, that is actually called the integral calculus, that suppose you have got y equals to function of x, you are differentiating it dy dx, you will be getting f dashed x, which is actually ddx of fx. Now if you want to get back the fx again, see, you can write this d of fx, ddx of fx equals to dy dx. Now see, if you take this dx eliminated from both sides, so d of fx is actually dy. So when fx is changing by very small intervals, y is also changing a very small interval. So if you integrate this, you will get back this fx and you will get back this y with a constant, which is called the constant of integration. So actually, if I discuss the integration, that is actually of two types. One is called indefinite integration, the second one is called definite integration. Where indefinite integration we are using, where the result will be variable, where definite integration we are using, the result will be constant. That is to be kept in mind very well. See, when we are doing about indefinite integration, see, we have to deal with a very important thing, that is called constant of integration. Suppose like this is the entire quantity x, you are segregating it by small elements, that is dx, and if you summed up all these dx together, so integration dx has to be x. But here we can't write integration x has to be x, we have to write it as x plus c. This is the rule of indefinite integration. When we are doing indefinite integration, we have to follow this, when integration dx equals to x plus c. Now here when we have this kind of indefinite approach, and why I am telling that differentiation is an integration, they are mutually the reverse process of each other. Suppose you have differentiated y, which was a function of x, which is x to the power n. Suppose you have differentiated dy dx and you got how much? That is nx to the power n minus 1. So if we differentiate this y equals to fx, that is x to the power n, you will surely get what? Nx to the power n minus 1. Now let's take that dy is actually nx to the power n minus 1 into dx. Now if I want to integrate this, if I integrate this, ultimately it will be what? It will be integration dy equals to this. Now how can you integrate a function? Suppose if you are integrating this function x to the power n dx, your result will be x to the power n plus 1 by n plus 1 plus c. Why? Because see, if you differentiate this one, I told integration and differentiation, they are just inverse process. If you differentiate this quantity, see, it will be what? 1 by n plus 1 is taken out, then n plus 1 is taken here, and x to the power n plus 1 minus 1 plus c's differentiation will be 0. This will go out, so the 1 minus 1 is 0. See, you will see that it will be x to the power n. By similarly here also you can see you have started with x to the power n, you got a result after integration, you differentiate that result after integration, and you will getting back the same function from where you have started. So integration and differentiation, they are the reversible formula for each other. So when you are representing like this n is taken out, so you are actually integrating x to the power n minus 1 dx. So n is taken out, x to the power n minus 1 plus 1 by n minus 1 plus 1. So ultimately n into x to the power n by n. So n goes out, and I know that by the methods, the process of indefinite integration, you have to give this c. So ultimately it is x to the power n plus c, because this what I told, integration is the reverse process of differentiation. If there was c, still if you differentiate this one, you will get back to this, because c's differentiation will be 0. And if c is not there, still the differentiation will give you the same result. So in indefinite integration, as the result is coming variable, because you can see in indefinite integration, when you are integrating something, its power of the variable is increasing. So that means the variable is maintaining its chain in the entire calculation. So to make the equation up to a limit of constancy, we should bring a constant that is called the constant of integration. But when we do a definite integration, which is also very much important, especially in terms of physics, when we do about the definite integration, the same result we will be following, but there the variable's value is limited within certain range. Like when you are integrating a function like f dash x dx, because you can't integrate a normal function until and unless it is a differentiated one. Suppose you are integrating fx dx from a limit a to b, that means the value of x is between a and b, where b is called the upper limit and the a is called the lower limit. So when these two you are having, so integration fx dx from a to b, your result, I told, whenever you are integrating something, your result is definitely a function of that variable with a higher power. So when you are integrating fx, your result has to be a function of x, let it be gx, and suppose its limit is between a and b. So what will be your final result of this calculation? That is g of b minus g of a. That is what? The final result is carrying the value range of the differential of the integrating variable between its lower limit and upper limit. So the process is, in the final result, put the upper limit minus lower limit. So this is the process by which you can do the differentiation, definite integration directly. So there is a process I told, that x to the power n dx, if I integrate between a to b, the same formula, it will be x to the power n plus 1 by n plus 1 from a to b. So 1 by n plus 1 will be taken out. It will be the upper limit. I am putting the b in place of x, b to the power n plus 1 minus lower limit a to the power n plus 1. So this is the concept of definite and indefinite integration. So indefinite integration, you need not to have any limits of the value. You have to put a constant c, that is called constants of integration. But for definite integration, you need not to bring any constant. There is always the result is coming out in the definite integration is always a constant, because the result is limited between two certain value limits. So indefinite integration is always giving me a constant result. Definite integration is always giving me a constant result, and indefinite integration is always giving me a variable result. So these are the difference between indefinite and definite integration. So there are definitely some formulas we need to remember. Suppose you get integration dx by x, you can write it as log x plus c if it is indefinite. If it is definite, you should write it as mod of log x plus c, like this. Suppose it is given as integration sin x dx, your result will be minus cos x plus c. All the formula I am writing for indefinite. Whenever you are going to use it for definite purpose, don't read the c there. Don't write the c there. Integration cos x dx, if I write, it will be sin x plus c. And one more thing, this formula I didn't write over there. It's so important for differentiation also, that ddx of tan x, this is a very important formula. It is always sec square x ddx of tan x. Like here also, if I integrate tan x dx, it will be, if I integrate tan x, log of mod tan x plus c, like this. So these are the variable formulas we have. Again, integration e to the power x dx, it will be same as e to the power x plus c. So these are the formula you must maintain whenever you are doing the calculation for variable integration and differentiation purposes, not only in physics, not only in mathematics, but in the entire field of science whenever you are applying calculus. So this calculus will be helping you not in physics, not in chemistry, in your entire higher study when you are somehow related with rate of change operation, that is called significance of derivative. Now let's come to the business end of this concept, that how it is closely related to physical purposes. There are so many, plenty of types of numerical problems that we can discuss on this particular idea. But before going into this, two last things I would like to explain here, that there are some variable types problem like incomplete differentiation. Like if y is function of x, I can write the complete differentiation dy dx. Like if y equals to fx, like x to the power n, I will get dy dx as nx to the power n minus 1. But suppose y is function of x, but I am differentiating with time. Suppose y is function of t and I am differentiating with respect to x, then what will be it? It will be like, suppose it is t to the power n. So what will be the change here? It will be n t to the power n minus 1. This is the general formula. But here you can see the time, y is not a function of x, it's a function of time. So there will be an incomplete derivative will be remaining here, like y equals to function of time. So I am differentiating with respect to x. So there will be an incomplete term remaining as dt dx. Like suppose y equals to x square, then if I write dy dx, it will be simply 2x. But y equals to t square, and I am writing dy dx, so it will be simply 2t dt dx, like this. So it's a chain rule. It's a chain is remaining as an incomplete derivative. So incomplete derivative is why it is important. We will discuss it later in different problems we know. Now I hope all the basic formulations of the application of calculus, which is so much relevant and so much related to the fields of kinematics, where the uniformity, non-uniformity of the motion is highly connected, we have discussed. Now it's our time to get into the problems entirely, that how much types of problem we can actually solve from this particular purpose, that I am going to do here. See, from here we are going to have multiple types of problems which is directly related to this particular point, which is known as application of calculus in motion. So let's have all these particular ideas together in our brain. We have to map it in everywhere that we can apply anytime in this chapter. Now suppose a very simple problem to start with. Let us have the particle's displacement x is given as a function t cube minus t square plus t plus 4. It is like this. And you are asked that at what time its velocity will be 0. That means you have to find out the time when velocity is 0 and acceleration is 0. So two different questions we have, that when velocity will be 0 from this particular equation and when acceleration will be 0 from this particular equation. Now see, if I differentiate this x, I will get v. So it is dx dt, so it will be 3t square minus 2t plus 1, because the differentiation of 4 has to be 0 here. Now this is our velocity we got. Now if I differentiate again this acceleration, so it has to be dv dt, so it has to be what? It has to be 6t minus 2. Now what is the term left for us? We have to find out the time intervals when velocity and acceleration was differently 0, separately 0. So if we put this v equals to 0, then 3t square minus 2t plus 1 equals to 0. Then definitely it's going to be either solved by middle term factor if it is possible, or it could be solved by Sridhar Acharya's equation. So it's 3, and we can segregate like 3 minus 1. So 3t square minus 3t plus t plus 1. So ultimately it is not getting, because it's minus 3t plus t. So either you can have the Sridhar Acharya equation from here. So if you get the Sridhar Acharya, the time will be plus 2 plus minus root over 4 minus 3 minus 4 into 3 into 1 divided by 2. You can see this is a negative terms coming. So time is coming imaginary, because 2 plus minus 4, here it is minus 12, so minus 8 and something coming. So this time is not relevant. So velocity cannot be 0 in any real time for this particular problem, but acceleration can be 0. Why? Because here t is unreal. What it is coming? T is unreal, because it is going to have 2 plus minus root over minus 8, that is root over 4 into 2. So it will be plus minus 2 root 2i divided by 2. Finally it will be what? Minus 1, minus 1, it's going to be plus. So it is 1 plus minus root 2i. So it will be a imaginary time, and time cannot be imaginary, so it is unreal. But acceleration can simply be 0. That 6t minus 2 is 0. So 6t equal to 2. So 2 and 6 goes. So t becomes 1 by 3 second. So at a time 1 by 3 second, the acceleration will be 0 for this particular problem. Again, we can ask one simple problem over here, that what will be the velocity and acceleration? A simpler problem than this. What will be velocity and what will be acceleration at t equals to 2 seconds? From this particular question, you can see you have got velocity, you have got acceleration. So at t equals to 2 seconds, velocity will be what? Velocity is 3t square minus 2t plus 1. So it's 3 into 2 square minus 2 into 2, it's plus 1. So it's 12 minus 4 plus 1. So 12 plus 1, 13 minus 4. So velocity will be 9 unit. So let in some question it can be given as meter. This is given as, obviously this is given as seconds. So you can write it as 9 unit or 9 meter per second. So from here the acceleration is 6t minus 2. So it is 6 into 2 minus 2, it's 10 unit you can write, or you can write 10 meter per second square. So this kind of relevant problems are very much important, where we are representing this kind of fields everywhere. Now from here, one thing we'd like to notify here, there's different types of problem now we are going towards. Suppose one simple type of question it is giving there, that is, for a moving object, suppose its displacement is proportional to cube of time. Suppose the displacement of the particle is proportional to cube of time. It has been asked that its acceleration, you have to identify its acceleration as option A, increasing, option B, negative, that is, it could be retardation also, option C, constant, and option D, decreasing. So these are the 4 options we have for this particular problem, when the displacement of the particle is directly proportional to the cube of time. Now, how can we solve this problem? That is not a big ask, but it's a relevant ask for our NEET exam. That is, this kind of questions are always important. From here, if I want to make an equation, I have to remove this proportionality sign and it will be s equals to kt cube, where k is a dimensionless proportionality constant. It is not going to hamper the dimension on both sides. Now if I differentiate single times the velocity v ds dt, it will be simply 3kt square. Again if I differentiate, I will get the acceleration, that is dv dt. So it is simply 6kt. Here 6k will be constant. So simply you can see here that a is proportional to time. That means if time increases with time, acceleration is increasing. So this will be my correct option, that here the acceleration is increasing in nature. So this type of questions are always important for us for this particular type of application. Now here from this particular concept, we are going towards the next problem. Like suppose for a moving for a particularly moving object, it is given that in a time t, the displacement time relation of the particle is t equals to root x plus 3, where remember t is given in second and x is given in meter. So time is given in second and x is given in meter, and t is related with x. How? T equals to root x plus 3. Now it has been asked that at what time or when, first of it, that when velocity is 0. Second question, when velocity is 0, find out its displacement. So these are the two questions we have from this particular given criteria. That is, when its velocity will be 0, a simple question. And another different question is, when velocity is 0, you got the time, right? So when velocity is 0, find out its displacement. So when you are doing it very popularly here, you can't differentiate like this. You have to make an independent x here. So root x equals to, you are getting t minus 3. If you square it on both sides, it is x equal to t minus 3 whole square. It will work for you in future. Now if I differentiate this, you will get the velocity dx dt, because t minus 3 means t square minus 6t plus 9. Now if I differentiate this on this differentiation, it will be what? It will be 2t minus 6. Now what was the condition asked? That when the velocity is 0. That means if the velocity is 0, so 2t minus 6 is 0. So 2t equals to 6. So t equals to, we got 3 seconds. So if time we got as 3 seconds, then surely we have to get the first answer we got. So we have got the first answer, that is 3 seconds. So first answer we got, that is t equal to 3 seconds from this particular calculation. That what was the first question? When the velocity will become 0. That we got the first answer, that at time equals to 3 seconds, or after the 3 seconds of the motion, the velocity will become 0. Now from here we want to have the second answer, that what will be the displacement when its velocity is 0. When its velocity is 0, at 3 seconds its velocity is 0. So at 3 seconds, what will be its displacement? We have x. I told this equation will help you in future, that x will be the displacement when its velocity is 0. It's 3 minus 3 whole square. So it is 0. So simply we can say from this calculation, when the velocity is 0 for this particle, its displacement is also 0. For this kind of problems, we are going through for this application of calculus, and you know these are so much interesting for us. Now let's have another very important problem from here, that when we are going to discuss this particular field, suppose we are showing a calculation like for this type of calculation, where you will have velocity, acceleration, and they are close in detailed relation with each other. Suppose it is given like velocity is given as, or the displacement is given as at cube minus bt square. It is given as at cube minus bt square. But we should remember one thing, that in this particular case, a and b not equals to 0, and they are constant. So if we differentiate a and b, they will be 0. Now the question is, find out the velocity when acceleration equals to 0. It can be a question, or they can ask you find out the acceleration when velocity is 0, or even they can ask you, find out the displacement, when velocity is 0, or acceleration is 0. So they are actually from a simple problem, from a simple numerical, I am basically asking you 4 questions together. So this is a modern approach and time-saving approach of study, that from a single question we can solve 4 multiple types of asking from one particular question. So S equals to AT cube minus BT square. Simply it is the given displacement for the particle, where T is the time obviously, and obviously A and B are non-zero constants. Now here if I write for velocity, it has to be ds dt, and what will be it? Simply it is 3at square minus 2bt. This will be the velocity. What will be the acceleration for this particular case? Acceleration will be simply dv dt. So it is 6at minus 2b. So these are the most important terms of this particular question, because you can see the entire questions given. Everything is related between velocity and acceleration. So velocity and accelerations are the deciding terms in this particular question. Now here velocity we have, look at the first question, we have to find out the velocity when acceleration is 0. So when acceleration is 0, when acceleration will be 0? Again this criteria is there, when acceleration is 0. So this will be the same time when acceleration is 0, and when it will be 0? When this term is 0. So 6at minus 2b equals to 0. So 6at equals to 2b. So 2 and 6 cancels out. So t equals to b by 3a. So this is the time interval when acceleration equals to 0. So acceleration equals to 0 when the time instant is b by 3a. Again, if I get when velocity equals to 0, velocity equals to 0 means 3at square minus 2bt equals to 0. So 3at square equals to 2bt. So tt goes out. So that time should be 2b by 3a. So 2b by 3a is the time interval when velocity is 0. So velocity is 0. That time interval is 2b by 3a. So these are the 2 time intervals which is mostly important in this question. Now what was my first question? That find out the velocity when acceleration equals to 0. Now tell me, what is the velocity expression? It is 3at square minus 2bt. Now when acceleration is 0 means what is the time? That is at time b equals to t equals to b by 3a. So at b by 3a, this velocity will be t square means b square by 9a square minus 2b into b by 3a. So this 3a goes out. It is b square by 3a minus 2b square by 3a. So it will be minus b square by 3a. So that is the first answer we have, that when acceleration equals to 0, velocity is minus b square by 3a. Again, when acceleration equals to 0, what will be the displacement? This was the expression of displacement. So under this time, when acceleration equals to 0, displacement will be a into b by 3a whole cube minus b into b by 3a whole square. So ultimately it is a into b cube by 27a cube minus b cube by 9a square. So this a goes out, it's for a square. It is ultimately 27a square. So finally it is b cube minus how much it is? It is 3b cube. So finally it will be coming as minus 2b cube by 27a square. So this will be the displacement when acceleration is equals to 0. When acceleration is 0, we will have this displacement. Now again the second 2 questions are left, that when velocity is at 0, what will be acceleration and what will be displacement. If the velocity is 0 means at this time, so at this time acceleration will be 6a into t stands for 2b by 3a minus 2b. So 3a, 6a cancels out, it will be 2. So simply it is 4b minus 2b. So acceleration will be 2b when velocity is 0. When velocity is 0, the acceleration will be 2b. Again, when velocity is 0, what will be the displacement? Again, what will be the displacement here? This is the displacement equation. A t cube. If I put this value there, t cube means what? It will be 8b cube minus 27a cube. Fine. Minus it is bt square. So it is b is there, and if I put it this square over here there, so it is 4b square by 9a square. So this a goes out, so it becomes a square. So on taking their LCM, it will be what? It will be simply as 27a square as the LCM. So it is 27a square as the LCM, and finally it is 8b cube minus 9 into 3, it is definitely 3 into 4. So finally it is 8b cube minus 12b cube. So it is minus 4b cube. So this will be the displacement when you have your velocity equals to 0. So these are the mutual correlations of velocity, displacement, acceleration, and they are becoming 0 here and there. That for these particular cases you can have from a simple problem we have discussed. When its velocity is 0, what will be displacement? When its acceleration 0, what will be its velocity? When its velocity is 0, what will be its acceleration? When its acceleration is 0, what will be its displacement? So there are too many questions we got solved here from one particular given set of conditions. Now, I hope it is clear. I have to make a fresh start from here also, that for new problem, new type of problem, that from here and from in today's class, we will not going through any integration related problem, that we are leaving for the next continuation part of this class. So we are focusing on all the differentiation type problems in this class. Now suppose we are given a problem like in any situation, suppose it is given that v equals to root over 49 plus 24x. v equals to root over 49 plus 24x meter per second, where x is the displacement, and it is also given in meter. So you have to find out what? You have to find out the velocity after 10 seconds. You have to find out the velocity after 10 seconds. This is a very, very important type of sums. Velocity after 10 seconds. See, this thing we can do it in two ways, but definitely we are thinking about NEET, where you have to solve one question in less than 1 minute time. So here we must follow the process which is most accurate and it should be less time consuming. So when we are solving this, I will definitely show the conventional two processes, and now it's up to you which is going to be easier to you. So if I do it for normal ways, it is v square. So it is 49 plus 24x. So definitely if I go for it, it will be like a differentiation where I get the acceleration by, if I differentiate this, it will be 2v dv dx. So it will be simply 24. So v dv dx, that will be the acceleration. So acceleration will become 12 meter per second square, and definitely you will get from this particular thing, if I compare, we will be really getting the acceleration, initial velocity and everything. See here, if I go for normal differentiation and the chain rule of differentiation function of when velocity is the function of displacement, by that way the finding out the initial velocity will not be that much difficult, because here we got the acceleration, and if we put the initial displacement when it is 0, because here velocity is the function of displacement, if we put it there, then it should be velocity is becoming root over 49, that is 7 meter per second. Now when x equals to 0, you know what is v? That is u, the initial velocity. So after 10 seconds, the velocity will be what? It is, you know, u plus at. So it is 7 plus 10 into 12. So it is 120 plus 7. So it has to be 127 meter per second. But for the special purpose of NEET, where you have to save time for some time killing questions that has to be there in the question paper to make you into troubled. So for avoiding those troubles for regarding time management, what you can do for this kind of cases, you can directly square it, and when you get the equation 49 plus 24x, you can write one thing very surely, that you know from the previous classes we have discussed that we have the famous equation of motion, which is v squared equals to u squared plus 2as. Here the displacement is x, so we can write it as 2ax. So here u square is comparable with 49. So definitely u becomes 7 meter per second. This 2a is definitely comparable with 24. So a, the acceleration becomes 12 meter per second square. So see, you don't need calculus. You don't need anything to do it. And you are easily getting what we got here by using so many calculus terms, these, that. So by comparing this, for this particular type of problem, you can get acceleration and initial velocity, and the rest is all common. You will get that v equals to u plus at. It is 7 plus 10 into 12, so it is 127 meter per second. Now this is what we are focusing on, this particular type of problem, where you can use calculus. It's totally your choice that what should be in your way, that how you can save the time for future use in the exam. Now from this particular question, when we are moving towards the next thing, that suppose from this particular things we are being asked, like suppose a coordinate of a moving particle is given as alpha t cube and beta t cube. It is like this, alpha t cube and beta t cube, where alpha, beta are non-zero and they are constants. That means if you differentiate them, it will be 0. That means obviously alpha and beta. Now they are asking you that at t equal to 2 seconds, what will be the value? Mod means the value, you know, you are even better knowing that modulus is giving us the absolute value of the variable. What will be the value, that is a mod of velocity and acceleration of the moving particle at or after t equal to 2 seconds. So how can we do it? It's a very important type of problem. Now clearly if the two coordinates are given, so you can easily see it, the variable, the particle moving in an xy plane, the particle is moving along the xy plane. So these two variables are actually comparable with xy. So if I write the displacement equation of the particle, so the displacement has to be the position vector. So the position vector r, as we know, it is xi cap plus yj cap, and here the position vector or the displacement vector with respect to origin, it has to be alpha t cube I cap plus beta t cube j cap. It is alpha t cube I cap plus beta t cube j cap, and if I differentiate this with respect to time, I will get the velocity, and what will be it? 3 alpha t square I cap plus 3 beta t square j cap. So this will be the velocity, and if I take the acceleration, it is simply dv dt. So if I take the dv dt here, it will be 6 alpha t I cap plus 6 beta t j cap. Now we are not being stabled here because this is, we are not going to have only the vector representation of velocity and acceleration. We need the modulus, that is the absolute value of velocity and acceleration. So if I want to have the mod v or only v, that is root over 3 alpha t square whole square plus 3 beta t square whole square. So definitely this 3t square whole square or 9t to the power 4 is taken common from these two, is going out as 3t square root over alpha square plus beta square. And if I take the mod of acceleration, it will be simply 6 alpha t whole square plus 6 beta t whole square. So 6t square is 36t square is taken common, is taken out. So 6t into root over alpha square plus beta square. Now here, this is the end of the question? No, never, it is not the end of the question, because look at the question given that at t equals to 2 seconds, this you need to apply in these two equations. So at t equals to 2 seconds, this 2 square is 4 into root over alpha square plus beta square. So it is 12 into root over alpha square plus beta square. So this is the magnitude of velocity. And what about the acceleration? The acceleration will be 6 into 2 into root over alpha square plus beta square. So acceleration will be 12. The mod of acceleration will be 12 into alpha square plus beta square. So one could have been the question, like they can ask you the ratio of velocity and acceleration here. That will be also alpha square and beta square going out. So finally it will be same. So 12 into alpha square plus beta square, and here also it is 12 alpha square plus beta square. So eventually it is moving like with uniform same velocity they are having. So velocity and acceleration, they are having the same magnitudes over here. So that is the important type of problem. Here we have this particular thing. Now from here we are going to the next type of problem. So here we are in our next problem. So suppose a particle is having an initial velocity like 3i cap plus 4j cap meter per second, and like after 10 seconds, suppose we have to find out the velocity at 10 seconds, obviously the magnitude of the velocity, where the acceleration, which is very, very important here, where the acceleration of the particle is given as root 3i cap plus 0.3i cap plus 0.4 j cap meter per second square. So these are the things given. We have to find out the velocity after 10 seconds. So students, don't get puzzled. It's a most easy question that we are discussing today. Now the important thing is that for this kind of problem, what we will do actually, see from here that one thing we must do, that we know the formula V equals to U plus AT, right? Here no calculus, nothing is needed. It's a simple, looks like a very difficult problem, but it's so easy, you know, that V equals to U plus AT. If I go for simple vector representation, it is U is 3i plus 4j cap plus this AT. A means here you have 0.3i cap plus 0.4j cap into 10, this much meter per second. So it is 3i cap and obviously plus 4j cap, again 3i cap, because 10 into 0.3 is 3, plus 4j cap meter per second. So finally if I write it, it is coming as 6i cap plus 8j cap meter per second. So is it the answer? No, I have to find out the magnitude of this velocity. So mod V will be simply root over 6 square plus 8 square meter per second. So it is 36 plus 64, that is 100. So root over 100 is 10, we know. So 10 meter per second. So these are the very relevant but most important type of, these are the short questions, simple questions what we can have for this particular idea when we are going to represent any type of motion, where the normal velocity equations and normal acceleration terms, they are also related in terms with vectors with this linear equations. So these are a simple type of question like this. We can move to another type of question like where the acceleration will be asked, that what type of acceleration it is having. Suppose it is given like that a particle is having a velocity which is related to displacement like this, V equals to k root over s. So we have to find out the nature of the acceleration. Similarly, like a previous problem, it will be given like the acceleration is negative, acceleration is infinite, acceleration is decreasing, acceleration is constant. So 4 options are there. The acceleration is negative, infinite, decreasing and constant. So whatever will be, we are doing the case of non-uniformity of the motion. So definitely you are thinking that it should not be constant, but it will be constant here. Why it will be constant? It's a very simple idea to know. That is v equals to k root s. We can do it in two manners, and it is up to you which one you will be going to do it. I will definitely advise you to go for the second way, because that will take the least time. Because here velocity is a function of s, so the acceleration must be having the very common term, that is v dv ds. So if I differentiate dv ds over here, what I will get? I will get this k as well. This half s I will get, and s to the power minus half. So that means k by 2 root s, it will be my dv ds. So my acceleration will be v dv ds. So k root s into k by 2 root s. So root s goes. So acceleration is equals to k square by 2. Acceleration is k square by 2. That we can remember from here, that acceleration is k square by 2. Now if the acceleration is k square by 2, so this clearly says as k is a constant, so definitely it is a constant. So acceleration, I told already, it has to be a constant here. But for this particular type of problem, I will advise you, I will request you to do that this type of question must be solved in an easier way. What is that way? You can simply square it. What you will get? You will get k square s. Now, I told you when we were discussing about the different formula of calculus, that if I differentiate like ddx of y square, it will be 2y dy dx, like this, y to the power n minus 1, like y to the power n to the n, y to the power n minus 1 dy dx, like this. So here also, if I differentiate both sides by s, here it will be simply k square, but here it will be like, if I differentiate with respect to s, dds of v square. I am just showing this term for your understanding, because you need not to do it for exam purposes. For k square into dds of s, it will be simply 1, and this will be what? 2v dv ds. 2v dv ds equals to k square into 1. So finally this 2 goes on this side. So v dv ds simply k square by 2. You need not to do a multiple calculation like the previous sum. So this is a very, very important type of question where you are easily getting the acceleration again, which is constant. So now children, you can see that which process is actually easier to you. That I am trying to represent here, that we must follow the quicker process and which is most accurate. So this should be our looking, that what is the accurate and what is the quicker process. So this should be we are looking for. Now from here, one thing we are going to discuss, that is from this particular point we are going to have a very important discussion, that velocity we got, acceleration we got, this type of problem we are discussing. Suppose a particle, it is given like a new type of problem. Why I am doing this, we will discuss its relevance in the next class, but this type of questions are so much important here. One question I have just introduced in the previous class, because that question is relevant to uniform motion and non-uniform motion also, because to solve those type of problem you need calculus, but end result of that motion is acceleration coming uniform. So it is showing a uniformity. So I discussed in the last class, again I will be discussing it here, that suppose s equals to vt. This is a working equation of a moving particle. So it is asked what is the nature of its acceleration. So simply what I can do it from here, it is 2s equals to vt. If I differentiate, it is 2 ds dt equals to v plus t dv dt. It's a method of two variable. We know differentiation, that this two formula we are working out here, u dv dx plus v du dx. This is one, and ddx of u by v square at the denominator, and in the numerator v du dx minus u dv dx. Now see, it is v plus t dv dt here. You can see 2 ds dt means 2v. Here this v is taken. So t into dv dt means a. That is the significance. So v equals to at. This is the representation. Now here you can have another differentiation of dv dt. So it is a into 1 plus t into dA dt. Now you can see dv dt stands for a. This is also a cancels out to be 0. So it is t into dA dt is 0. Now here, as we know that since time can never be 0, so dA dt has to be 0. So when the differentiation of a variable is 0, that variable is not anymore a variable. That a must be, any quantity's differentiation 0 means the quantity is constant. So this type of questions are always there. We should discuss it every time. So this type of questions are very much important for motions like this. So this we have to consider for different types of motion that are relevant in our everyday motion purposes. Now one problem, I was telling that one problem I will discuss, but its major relevances will be in the next question. For that I am just giving a simple concept. Suppose it is given that velocity you have is 2t, like this. Velocity you have 2t meter per second. It is been asked what is your displacement. It is been asked that what is your displacement at t equals to 2 seconds. It is been asked. So majority of this type of problem we will be doing in the next class, but I am just giving an introduction to finish up today's lecture. Now v equals to ds dt we have. ds dt equals to 2t, right? So if ds dt equals to 2t, so ds equals to 2t dt. Now if I integrate on both sides, so it is 2 outside, it is integration ds into 2 integration dt. Now integration ds will be s, we know. Now it is between, so motion is starting from, definitely it should be 0 to 2 seconds. So 0 to t dt will be the result. Now if I integrate t, it will be t square by 2 according to the formula that x to the power n dx equals to x to the power n plus 1 by n plus 1. Now it is a differentiation which is definite. So no c here, no constant of integration. Upper limit is 2, lower limit is 0. This 2 goes out. So upper limit is 2 square minus 0 square. So finally it is 4 meter. So this type of problem, it's quite obvious. When velocity is given, if you are asked to find out the displacement, your instinct is telling that I have to differentiate, I have to integrate, because I have to get back to the previous function. Because displacement's differentiation is velocity. So if I can integrate, because integration is the reverse process of differentiation. So if I integrate velocity, I will surely get the displacement. But it is not true every time, dear, because whenever we are given like problem like this, see, it looks like that it will be a simple integration type problem, but the problem which is there, that there is a mathematical trick. It is given for the mod. Suppose a particle or a bird is flying for a time interval of 0 to 4 seconds. A bird is flying a time interval of 0 to 4 seconds. So definitely in anyone's mind it will strike like this is the span of lower and upper limits of time, and this is the velocity. I have to integrate like v equals to ds dt, whatever we have done here. But we can't do here because it is a mod it is taken. So mod, there should be plus of minus t minus 2 and minus of t minus 2, and the time is taken a negative parameter and it will be somehow adjusted. So how we can adjust that in terms of integration? That is a big query of this question. So for this type of question, we can't apply direct calculus, and we can apply a very simple method what we studied in class 9 level when we first learned about the graphical approach of motion. So graphical approach and integrational approach, we will do it in the next class. I told, according to chapter breakup, you can see the non-uniformity of the motion is disgraced into 2 particular lecture. So first lecture is almost at the business end of the first lecture we are in. So we have to discuss it like when time equals to 0, v equals to mod minus 2, that is 2 meter per second. When t equals to 1, v equals to mod minus 1, that is 1 meter per second. When t equals to 2, v equals to 0. When t equals to 3, v equals to 1 meter per second. When t equals to 4, v equals to 2 meter per second. So children, you can see that never ever the velocity, whatever be the time is, it is not varying beyond 2 or below 0. So the velocity is changing between 0 to 2 in the interval of 0 to 4 seconds. Now if I draw a graph, simply if I draw a graph that is tending between one side is time and one side is velocity, and it is striking from 0 with the origin, and here the velocity you can see maximum it can run up to 1 and 2, and the time you can have 1, 2, 3 and 4 seconds. So velocity in meter per second, time is in second, and if you plot the graph at time equal to 0, your velocity is 2 meter per second. At time equals to 1 second, your velocity is 1 meter per second. When time equals to 2 seconds, your velocity is 0. When time equals to 3 seconds, his velocity is 1 again. And when time is equals to 4 seconds, your velocity is 2 again. So in a span of 0 to 4 seconds, you are actually traveling on a velocity time graph two identical areas of two right angle triangle. And we know from our basic knowledge, we have done it from class 9 onwards, that in a velocity time graph, the displacement is always measured by the area under the graph. So from this particular problem, what will be the distance traveled here? That is the twice of the area of these triangles, because they are having equal area both. So 2 into half into base into height. So how much it is coming? It is as 2 goes. So the area of these two triangles is giving me the distance, and this will be the distance traveled in this particular time interval of 0 to 4 seconds. So students, it is so amazing. See, we are so much prepared instinctively that our instinct was saying, our will was saying that we have to integrate this type of question. So relevant to it, velocity was given, we were asked the displacement, same type of question. But here I haven't used calculus because I am bound to not to use it everywhere. So we are free to use calculus and non-calculus approach in plenty of different options. So hopefully whatever we discussed in this class, it's clear to you, and definitely we are moving towards our next class very soon, and you will be seeing on the different applications of integral calculus and the graphical approach of non-uniformity of the motion in the next class. So today I am signing out. We'll be meeting you very soon. Take care of yourself, stay fit and fine, healthy. We'll be back very soon with the next continuing part of kinematics.